Paige Tucker.
Thank you so much. I'm going to respect the time. I know we're limited on time, so I think I'm just going to go ahead and jump right into the presentation. Some of you may be more familiar with the company than others, but I'm going to assume that you know very little about the company. So, my name is Paige Tucker. I'm the CEO and founder of ProStar. What is ProStar? ProStar is a world leader in the development of precision mapping solutions, and I like to explain in layman terms what I mean about that. Most of you familiar with Google Maps. We probably use it when we're traveling to get from point A to point B. Google Maps provides what's called line of sight. So the accuracy is based on the GPS chip embedded in the device, which is about 3 to 5 meters. We've designed our own proprietary mapping system that works like Google Maps, but again, it's proprietary. It's accurate to 1 centimeter. The name of our flagship product is called PointMan. PointMan is a cloud and mobile application, and we sell it based on a SaaS revenue model. So our clients pay us annually to use our cloud and mobile software solution. Here's my forward-looking statements, confidential information. You can find it on our deck on the website, which I highly recommend that you do. So a few things to know about PointMan. Number one, PointMan is designed to provide the ability to capture, record, and display critical infrastructure both above and below the ground. It's proven to significantly improve all of the workflow processes and business practices associated to either the construction, the maintenance, or management of critical infrastructure. And today we have clients, a growing list of clients, I'm proud to say, that include Fortune 500 construction companies, government agencies, and some of the largest engineering surveying firms, not just in the US or Canada, but also abroad. I'm not going to get into too much detail. Again, this information is available on our website, but we have a very, very experienced management team that covers all facets of operations, including our CFO for finance, capital markets, operations, scaling SaaS companies, and backgrounds in data management and also what's called geographic information systems. The same with our board. In fact, the last board member that just came on board, his name is Wayne Moore. Wayne is the former managing director, partner, and founder of the Mergers and Acquisition Division for Goldman Sachs. PointMan is designed to benefit any industry that's impacted by not knowing where buried utilities and pipelines are located. And that includes construction, Department of Transportation, oil and gas, engineering and surveying, railway, municipalities, mining, as well as utilities. And today, I'm pleased to say that we're actually gaining footprint in each one of those industries. We also have a very extensive IP portfolio, which is a pretty strong indicator that we are the leader in first to market. In fact, we have 18 issued patents, of which I'm actually prosecuting as we speak. I've been ordered by the judge actually to try and do mediation. I'll be in New York on the 17th. When I talk about infrastructure, most people think about the infrastructure bill, $1.2 trillion infrastructure bill. And then they think of our roads and our bridges and our highways that are becoming dilapidated and in serious need of repair and replacement. But there's also several hundreds of billions of dollars that's earmarked for another infrastructure. It's the one that's buried below the ground. So our water systems, sewage systems, and expansion of broadband. The point of it is that these two infrastructures are actually connected. But I want to put things in perspective. There's 2.5 million miles of paved roads that crisscross our nation. That's a pretty vast network of paved roads. But it pales in comparison to over 35 million miles of buried utilities, of which the majority of them were put into the ground between 50 to 100 years ago. But again, as I mentioned, these two infrastructures are interconnected. You cannot work on one without impacting the other. So with all of this money that's going to be pouring into construction to improve our roadway systems as well as the underground infrastructure, there's a high probability that the amount of damages that are going to be incurred are going to go up exponentially, because the reality of it is no one really knows where these utilities and pipelines are buried, not to any level of what we refer to as geospatial accuracy. This is what it would look like in any major city if I removed the pavement. I refer to it as a spaghetti bowl of utilities and pipelines that have been haphazardly thrown into the ground over the past 100 years. As I indicated, the majority of utilities and pipelines were put in the ground between 50 to 100 years ago, well before we had any type of compliance regulation or oversight, and it was never intended to support the level of population growth that we've experienced over the last 100 years. 500,000 times a year we hit a utility or pipeline during construction. That is a lot of strikes on utilities and pipelines, and these are the incidences that are reported. But that equates to every minute of every working day we hit a utility or pipeline during construction. And when you hit a utility or pipeline, some bad things can happen. You can have serious flooding, we can have traffic delays for several hours, our businesses can be interrupted, we can have dangerous petroleum products that are seeping into our water systems. Or, in worst case scenario, if you hit a high pressure gas line, there's a high probability you're going to have an explosion. And when you do, serious injuries incurred either by the worker or the public, or we could actually have loss of life. And in fact, the loss of life number is only going up every single year. It's estimated we spend $10 billion every year, just in the United States, trying to identify where these utilities and pipelines are located. And yet it's estimated we have over $30 billion worth of damage to our economy. So whatever we're doing, it's not working very well. It's not too effective. Part of the problem is that I said 50 to 100 years ago, we had very little oversight or compliance. No one was really worried about where these utilities were going into the ground. It might surprise you in the last 50 years, including today, the way that we map the location of a utility or pipeline is actually on paper maps. These are called as-built drawings. These are the original planning and design drawings on how these utilities and pipelines were intended to go into the ground. And yet how we plan for them to go in the ground and how they actually go into the ground are two different case scenarios, for good reasons. Ground conditions could be too harsh. There could be some type of obstacles that are in the way, or they could be overpopulated with existing utilities where they have permission to place the utility or pipeline. So the contractor who puts them in the ground, he'll move over maybe 2 or 3 meters, or sometimes even on the other side of the street. Put them in the ground, bury them, pave over top of them. The regulators come out, and as long as it's within the roadway, they'll sign off on these as-built drawings, which creates a problem. They become the system of record, which means they're inaccurate by nature. Another problem plaguing the industry is actually how we try and identify where utilities and pipelines are located. Every state has a one-call center. Probably heard of 811, a call before you dig. You're required by law to call into the 811 center and notify them where you're going to be doing construction that requires digging activity. Then what the center does, as best as they can, they take all the information that's available, if there is any information available, and try and determine which utility or pipeline company is going to be impacted by that construction. Then they notify them they have to come out and mark where their utilities and pipelines are located. They use what's called an electromagnetic pipe and cable locating device, which is what's in that gentleman's right hand, which the majority of the time will locate where a utility or pipeline is. The problem is they use a spray paint can to draw on the ground where that utility or pipeline is. In fact, from here on out, starting today, you're going to start seeing these paint marks all over the road, all over the sidewalk, in front of your house. Now you know what they are. They're supposed to represent where a utility or pipeline is located. At best, just because of human error, that paint mark is accurate to about 1 meter. In addition to that, I don't know if they've mistaken a fiber optic line for a power line. I don't even know if they located a utility line at all, because the fact of the matter is they get paid to put paint marks on the ground. The construction companies, the engineering surveying firms, and the excavating companies that take on all the liability, they don't trust those paint marks at all. What they do is they bring in this big hydrovac truck. The hydrovac truck is designed to drill a hole in the ground right over top of the pavement, suck all the dirt out through that giant vacuum in an attempt to expose the utility line in order to determine if that paint mark was correct. If they don't find it, they'll move it over a couple feet and they'll drill another hole in the ground. These holes that they're drilling cost between $1,000 to $2,500 per hole. We've worked with companies that have drilled 50 to 60,000 of these holes on large projects. But this is what the companies are forced to do because the risk of hitting a major petroleum line, a gas line, or a fiber optic line is far too risky. But again, very onerous process, very time consuming, and very costly. Another problem plaguing this industry is the way that they've actually managed their workflow processes of the data for the last 30 years. So you send a locator out there, puts a paint mark on the ground, or you send the hydrovac truck out to actually expose it. Then they send a surveying crew out there to survey in the paint mark or where the hole in the ground was, export the data onto a PC out in the field. Someone has to review and qualify that data. Then they export it back to the office where it's imported into their system of record, which is either a CAD or GIS system. Once the data is finally qualified, they send it back out into the field. On average, we're told that takes about 2 weeks. It can easily take up to a month. Some government agencies have told us that's taken over a year. Now, with all the technology that's readily available, innovation that's being created in other industries, you'd think that the construction industry would also adopt technology, but they're known as a laggard. They're actually ranked number 50 in the world, which also means they're ripe for disruption. That's why we created a simple mobile app. You can download it onto any smartphone or tablet, and we significantly streamline those workflow processes, the business practices, and we also create automation. So the question becomes, how do we do it? Well, number one, when you collect the data on our system, it goes right from the mobile device up to the cloud, and it's available to whoever needs it in the field or in the office in less than 1 second. It's a pretty simple process. We take the cable and pipe locating device. Through Bluetooth technology, we pair it to any smart device, including, as I mentioned, a phone you might have within arm's reach or a tablet, running our point man software. Then we pair it to a precision GPS receiver. This one here is called the DA2. It's developed by Trimble. It's about twice the size of a hockey puck. This is not the chip that's embedded in the mobile device. This is an external GPS receiver that will provide centimeter accuracy. Once the data is collected from the locating device onto the mobile device, it goes up to our cloud. We run it through our proprietary algorithms, and then again make that information readily available to whoever needs it in less than 1 second. This is what it looks like. You can see that the locating device is paired to the precision GPS receiver. And what we're doing on the mobile device is not only capturing precisely where the utility is located, we're also capturing very critical metadata that's available from both the locate device and from the receiver, which provides the accuracy and the confidence level that when we say that's where that utility is, you can trust the information. For example, what type of locate device, how deep it is in the ground, the currency and frequency will tell us what type of utility it is. If you scroll down, you see vertical precision, 1.3 centimeters. How do we know that? Because right below it, it said there was 21 satellites in view. We're actually capturing what's called the NEMA string data. This is the accuracy provided from each satellite. That's what we're running through our proprietary algorithms to determine, again, the accuracy and the confidence level that's being provided from those devices. We can also take their existing data and stream it out onto the mobile device so they can see where their existing as-built data indicates where the utility or pipeline is located in comparison to where it's actually located. At a click of a button, you can measure the discrepancy of the distance, and all of this can be viewed in real time from the office. So if I had 20, 30, 40 field crews out there, I can actually see them in real time as they're collecting the data. Then I can take a look at the data and see how accurate that information is, and at a click of a button, I can consume that data off of those mobile devices onto their system of records so they can update their existing records. We also integrate into 811 and other systems. That's how we create automation and improve the workflow process. We also digitize forms. So for example, we can take the one-call ticket, display it out on the devices so they can see where they have to do the locate. At a click of a button, we've built what we call geospatial intelligence, meaning the mobile device knows where you're standing. If I need to open up a locate form, it'll auto-populate it. If I need to take photos, it embeds right into the device. You can use notes utilizing voice to text. You can also do a digital sketch right on the map that's on the mobile device. The way they do it today is sometimes on a piece of paper or even on a napkin, which means all of this information can be observed from the office. So I don't need to send an engineer or a surveying crew out there. This is actually survey-grade data that can be viewed from the office. They can see the data that's coming in and then determine the level of accuracy. This is important because the American Society for Civil Engineers, after 20 years, just changed all their guidelines and standards, and it's based on PointMan, our software. It's based on the precision of the data we can provide, the photos that are geo-referenced with the notes, and a digital sketch. And as a result, after 20 years, they just recently changed their guidelines and standards. About 4 years ago, when we completed the development of the software, I said, hey, let's go out and get some big companies that can influence adoption in the market. One of the companies I showed it to was Kiewit. They're the largest infrastructure construction company in North America. When I showed them what we had, they said, you might have the holy grail of the construction industry if this works. What do you want us to do? I said, I want you to pay us, sign a contract with us, and test it. They said, okay, we're going to put you on the I-70 expansion. It's 11 miles of the busiest section of the busiest interstate in the United States, right through the heart of Denver. We're going to be relocating subdivisions and moving sections of the interstate. It's going to take about 5 years, total cost of about $5 billion, and it's a partnership actually with Colorado Department of Transportation. I said, perfect. After 1 year of testing, it was so successful that we reduced utility strikes by almost 100%. That can be a cost savings, depending on the size of the project, to anywhere to $20 to $50 million. It was so successful, they moved us into water, power, light rail. Then we signed a master services agreement with them, and now they're pushing us out into multiple projects and multiple divisions. Then I asked CDOT, because they owned I-70, if they would also sign an agreement with us and test it, and they said yes. After about 18 months of testing our software, the state of Colorado mandated point man into state law. That means that every construction company, utility company, engineering surveying firm, anyone that owns, maintains, or constructs a utility or pipeline on a state right-of-way is required to use our software by law. Now I have several other states I'm in negotiations with. I just sent a proposal out to Pennsylvania DOT, and I have met actually with Caltrans, which is called California Department of Transportation, on several occasions. I say with a high level of confidence that every state DOT will move over to a system like PointMan. Just a question of whose is it. Then I took it to 3 of the largest engineering surveying firms, one in Canada, one in the United States, and one in Australia, and asked them to work with us as trusted testers to build the business rules into PointMan to meet all the requirements of these engineering surveying firms. After about 18 months of working very closely with them, all of them adopted our software, and that's when we knew we had something that we could start pushing out in the market. So it took us about 4 years to get to the point where we had 5 very credible companies utilizing our software. Then what's happened in about the last 18 months is we're starting to see a little bit of an inflection point in multiple industries, including largest mining companies in the world. We just signed a ski resort. We have heavy construction companies that pave roads using our system. We've got universities, municipalities. Again, any industry that's impacted by not knowing where utilities and pipelines are located would benefit from using our software. And today our software is designed to work anywhere in the world. I have several companies in Australia utilizing our system, so we're starting to expand into other parts of the world. I also partnered with all the manufacturers around the world that develop either the GPS equipment or the devices that are required to identify where the utilities and pipelines are located. To partner with us, I asked for seamless integration into their firmware. And in fact, Radio Detection, which is the leader in the world of developing the cable and pipe locating devices, recently signed with us a worldwide commercial distribution deal where they're going to start selling PointMan with each device that they sell. And I think once one does it, if it becomes a key differentiator over the others, then they're all going to follow suit. In fact, we're training 50 of their salespeople right now worldwide. But if anything else, it gives us a great distribution channel and network worldwide, but also the credibility that we have something of value based on the fact they open up their firmware to us. There's 2 ways we sell our software. It's pretty simple. You can buy just a mobile app for $495 a year. Works anywhere in the world, integrates into the GPS devices as well as the utility locating devices, but you're limited by the amount of data that you can store remotely on the mobile device. But at least it gets them started, and they can test it and they can use it. And then to move up to our full cloud and mobile solution, it starts out at a very attractive price of only $6,000 a year. In fact, Taos the Ski Resort is running their entire ski resort for $6,000 a year. Our competitor charges about $200,000 a year, and then you need a resource that knows how to operate the system, which requires a 4-year college education, so you're into it for about $300 grand a year. We can train anyone to use our system inside the organization in about 2 hours. It's $6,000 to start, and then it's $2,000 per app after that, so $2,000 per license. So we have it priced so inexpensively that we can get in there, and then the goal is to land and expand and let them decide how many devices they would need. But again, we can utilize this to operate a small ski resort, a large city, or some of the largest construction companies in the world. We're projecting to do about $3 million in revenue this year. We need to get to about 4.25 in order to be cash flow positive, and we're projecting that'll be about this time next year. These are very conservative estimates. As you can see, I don't have any type of hockey stick trajectory in there, but I can assure you that we do have the capability to experience an inflection point like that. As I mentioned, our software is designed to work anywhere in the world. We're infinitely scalable, anywhere, any language, and we're starting to see adoption in other parts of the world. Here's my cap table. I have 128 million shares outstanding right now. We have 146 million when we're fully diluted. Out of those warrants, on the second line item down, there's 13 million out of those 19 million that will fall off on November 24th, which will clean up our cap table. We have about $2 million cash in the bank right now, and we are debt-free. Now I have a few minutes left to answer any questions that any of you might have. Yes, sir.
So, do you understand correctly that your client will pay for your app, will do the testing to put the data in the app, and then use the app to access their own data that they put in while doing the testing?
Correct.
So you can basically get paid for them to organize their own work, more or less.
That's correct. So we become the database, we become the system of record where they store all of their project data. And we don't charge them for any amount of data that they store, it's unlimited. And then anytime they need that information or go back to that information, they have a system of record of where it's stored. But it also becomes a digital imprint that they can deliver to their client, which historically never occurred. Normally, once a project's done, no one managed that data, stored it, or shared it. Now we have a central database repository where they can, number one, store that data for their own purposes, but they can also share that data and deliver it to the client.
So is it owned by the government? Is it owned by you? Is it owned by
the client?
The client, okay.
The client owns the data.
Okay.
Yes.
You noted before that one of the challenges with the EM locators is the guy who's out there using the device doesn't know if he's looking at a power line, a fiber line. You don't solve that problem for them, so they may go out there, use the device, create their new record, and it's wrong. They've identified the wrong thing.
No, we solve it. That's why the American Society for Civil Engineers just adopted our software as a standard. We can tell what type of utility line they located. We can tell if they located it, how deep it's in the ground, and the accuracy.
How do you determine that?
It's based on the information that's being provided from the device. So you can pick up the currency and the frequency, you dial that into the locate device. When you're over top of it, think of it as like a metal detector. It'll tell if you're within, say, 90% tolerance, 97, or 100%, which means you're right over top of it. The currency and frequency that you dialed in will determine if it's a fiber optic line, whose fiber optic line it is, if it's a cable line, or if it's a power line. They all have what's called a unique identifier, which is based on frequency and currency. If it's metal, which is normally a sewage system or a water system, that's the easiest one to locate, because you hook up an electrical charge to it, and then you know exactly when you hit that charge.
Why weren't they doing that before? I mean,
they were never collecting the data. They haven't collected the data in 30 years. They put a paint mark on the ground. No one thought of, number one, integrating a precision GPS receiver to those devices. And by the way, you need Bluetooth technology to do that, which when I wrote it, patents didn't exist.
But you don't need GPS to figure out what happened.
You absolutely have to have the GPS to determine the geospatial location of that utility or pipeline.
The location, but not what type of infrastructure.
Why weren't they capturing that information before? It's a good question. No one thought of it, but they weren't. And in addition to that, I'm sorry, it was heavily endorsed and supported by the fact that these big companies get paid to put paint marks on the ground. So why would I want to collect the data knowing that I'll have to go back out there tomorrow and collect it again? On our system, you collect it one time, you won't have to go out and relocate it. But the big locate companies don't want that. The equipment manufacturers don't want that, because I'll reduce the amount of locating that's taking place. And if you install it with our system, you never have to locate it. Yes? I'll take two more. Three more, here we go.
Yeah.
It's like Jeopardy. Boom, boom,
With
boom.
the projected revenue growth, any plan to uplist?
Good question. Yeah, obviously we're on the venture right now and we're on the OTC. The ultimate goal and why I started this company is I'd love to ring the bell at NASDAQ, even though it's not really a bell anymore. But the goal is to uplist. But the reality of it is, we're a minimum of 2 years out from that, and we have to execute and check a lot of boxes before we can even think about that, but the goal is ultimately to uplist.
This
Yes,
organization behind the 811 calls, is that a state database? And why wouldn't they be a client if you're improving their?
we're now integrating into 811. I'm just having conversations right now with one of the largest 811 ticket providers to integrate into their system, because it will streamline everyone's processes and add value to their system. We got one more question. I can take 3 seconds. Go.
So this is
Oh,
fascinating,
yeah.
but we are on time.
Perfect. I appreciate
Thank you,
everyone's
Mr.
time.